Hi, I'm Abby Ertzbischoff, and I'm currently a student at Colorado Mountain College. And this summer, I was a research intern with Yampa Valley Sustainability Council, but my program also partnered with Center for Western Weather and Water Extremes in San Diego. So my project looks a little different than the ones you've seen so far today. I was working on in situ or on-site soil moisture monitoring in the Yampa Basin. I was creating baseline data as well as a protocol for a citizen science program that YVSC is hoping to get going. I just really quick wanted to thank my mentors who I wouldn't have been able to do this project without their help and their guidance the whole time. Madison Muxworthy, who's a soil moisture, water and snow program manager at YVSC. Michelle Stewart, who's the executive director at YVSC, and Nathan Stewart, who's a professor of ecosystem science and sustainability at CMC. So why does soil moisture matter? Why do we care about soil moisture? Well, it's a huge factor in determining the amount of runoff that will occur from snowmelt, and therefore the likelihood of droughts and floods that may occur in an area. Mountain snowpack and snowmelt drive stream flows are a critical water resource for a sixth of the global population, which is about 1 billion people, including all of us here in this room. So what does that really mean when our soil is really dry and the snow melts or there's precipitation of it happens? All of that water is going to be absorbed into the soil before it can get into our streams, into our waterways, into our agricultural land, into our houses. So it's pretty important to have to understand how the soil moisture is. So we actually already monitor soil moisture quite a bit. There are a network of SNOTEL stations run by NRCS all over the nation, and they've been monitoring soil moisture since the 90s. And then YVSC has a station called the Ski Station out in Stagecoach. They put out recently. It does a ton of stuff, but most importantly, soil moisture. You'll see the soil moisture pit over there in the corner. That is just a pit, a 45-inch hole you dig, and you put soil moisture meters in there, put dirt on top of it, and you let that just kind of run and keep taking data at that location. So it'll take continuous measurements. So why do we want to engage the public in these long-term research projects? Why does it matter that we involve them? Well, a couple of the key objectives of that citizen science program is to increase the range, number, frequency of the data that we collect, to increase citizens' understanding of why soil moisture matters, and to increase citizen involvement in this long-term soil moisture data collection and the analysis of that. Citizen science has a lot of value. But most importantly, I think it provides us with a lot of extra data that we wouldn't otherwise have. It also increases that project scope and intensity because of all that extra data we can get. And most importantly, it increases the stewardship and awareness of citizens in our community of these kind of projects and why they matter. So I created a pretty simple research question. How do in situ soil moisture measurements vary over an elevational gradient in the sort of southern Rocky Mountains, I believe it says, which you'll see in a second. Dominated water, snowmelt water, dominated watershed. Okay, so I needed to create a site location, and I also needed to create a field protocol. And when creating those things, I wanted to make them accessible, replicable, and meaningful. And by that, I mean, I didn't want citizens running bushwhacking through bear country to get soil moisture measurements. I wanted it to be an accessible location. I wanted this location to be somewhere that you can continuously go back to and somewhere that was meaningful to the citizens of the area. But I also wanted to create a field protocol that was accessible to anyone so that anyone could do it, anyone could repeat this process, but also that the data coming from this would be meaningful to us. But does anyone recognize this trail, perhaps? Just curious. It's kind of a random picture, but it's so this is Spring Creek Trail, which is in the heart of Steamboat. The yellow highlighted section is just the most popular area. It actually goes all the way north to Buffalo Pass. And you'll see here my 5 site locations that I chose and the elevational gradient that they go over. So along Spring Creek Trail, right next to it runs the Spring Creek, and that Spring Creek runs into the Yampa River, and Yampa goes right into the Green River, which goes into the Colorado River, which is a really important river to a lot of states. So that was kind of a huge reason why I chose this location. Spring Creek's a really awesome trail. It's in the middle of a valley, so it's really shady and has a lot of trees. The creek running next to it's really beautiful. Dogs love to swim in it. It's a good trail for kids. We had a stream gauging system there for a number of years. It's currently out of commission. And you'll see the location over there. There's a couple of reservoirs there. There's a dog park, a gazebo. People love to hang out there. And then my location marked in red is just a mile or so above the reservoirs there. So Steamboat's history with Spring Creek actually goes back pretty far. It was the first running water source for Steamboat. These wood stave pipes ran water from the reservoirs down into town, into people's homes in the early 1900s, which was pretty rare for the area at the time. So it made Steamboat a pretty fancy area to visit and to, you know, to live in. So when I was at Spring Creek, I took soil moisture measurements with a TDR, which is that device in the corner over there, a 4.8-inch meter to get the volumetric water content of the soil. I also took soil cores, which I took the wet weight when I was on site, and then I dried them at home and took the dry weight. I also took a vegetation classification by percent while I was there. The slope angle and aspect, as well as the elevation. And you'll see at the site, so from the trail, about, you know, at 4 feet from the trail, I put a marker that will stay there as the long-term ecological research site where people can go back and take measurements. And then from that site, I went up 3 meters and then 6 meters from there, and also took measurements there. These are all up elevation from the trail to kind of avoid the influence of the trail. And the results of my TDR volumetric water content are pretty interesting. The content, you know, is between 3 and 6% on all of those, except for your notice at site 3A is pretty drastically higher than all the rest of them. So you can see that their vegetation cover is quite different at all the different locations. The ones dominated by orange are mostly dominated by woody shrubs like sarvisberry or bramble oaks. The light green is dominated by a grass, but you'll see site 3 is pretty different from all of them, even though they all vary. And just to show you a little closer what that looks like, it'll switch in a second. Okay. I don't know why it's not switching. There's a picture of one site and then a closer up of 3. Go back. There we go. Okay, so site 1 you can see has a pretty large variation of vegetation of trees, but site 3 is pretty homogeneously this grass type. It's also pretty sunny. So I would predict that it had something to do with the vegetation, but it'd be really interesting to continue to go back to these sites and watch how over time throughout the year that these sites change and the vegetation changes and the soil moisture to see what aspects of that actually influence the soil moisture at that site. I also compared the TDR soil moisture measurement with the soil core volumetric water content. Oh, okay. So to get the volumetric water content from the core, I just took the wet weight minus the dry weight divided by the volume of that. And at first it kind of looked pretty comparable, but I wanted to see if there was an actual statistical difference. So I did a statistical difference test, a t-test, and that came out with a 95% certainty level that there was an actual statistical difference between these two measurements, between the TDR measurement and the calculated measurement that I took. And so I sort of concluded from that these in situ measurements are really valuable and need to be taken to ground truth calculation measurements that we might have, as well as water managers need to be able to consider multiple sources of soil moisture data to be able to inform their decision making. And these handheld measurements need to be one of those because they are important and can show us things that we might otherwise not be able to see. Some other conclusions that I came to: long-term ecological research can show trends that otherwise might be missed. Soil moisture depends on a lot of factors, which might make it really hard to predict. And citizen engagement is really important in their involvement in field research is really important. And science is really fun, like when you get to do handstands and polls. And so next steps, I would suggest that we continue. I would really love to see this project continued and to be able to continue that to the baseline data that I took, the soil moisture measurements, as well as the site photo. I think we should continue to commit to this continuous monitoring, as well as engaging the public, like people, all Steamboat locals, anyone likes to go outside, students, young students, as well as CMC students, like Chloe said, we just want to do really fun stuff. And creating standard methods at all locations and to look at national forest land, public land, and recreational areas for continuing this project to expanding it to other locations. And then I really quickly just wanted to thank Katie Adams at the Treader Pioneers Museum. She's a curator there. She gave me all of the information about Steamboat's history, which otherwise I wouldn't have had. All of the staff at YVSC, I've loved working with you guys. It's been so awesome, as well as the interns. I've loved seeing your projects. All of the staff at CW3E and the interns there I've got to see grow, and all my friends at Aspen Global Change Institute. Any questions? Abby.
The citizen science portion, is there like Like, how much knowledge would people need? Like, would there be a learning curve for people to start taking that data, or is it pretty simple?
I think it would be pretty simple. We don't yet know the devices that we would want them to use. That would be part of it, is we want to make them really simple. We would have them come to the office and teach them how to use the device hopefully pretty quickly, and then send them off, and they would be able to do all the field stuff by themselves. The site photo is really simple. It's a really specific location you stand in. And yeah, the soil moisture, the monitor, you just stick in and click a button. It tells you all you need to know. So it's pretty simple. Very informative.
From Nathan, sir, great presentation. Abby. Do you have a sense of how Spring Creek vegetation or soil might change under dying and warming at your sites?
That's super hard to predict, because we haven't been monitoring there. Nobody has ever monitored there before. I do know that a lot of locals that live in like by Spring Creek were walking by me as I was taking these measurements, asking me like, how's the soil look? It's been a really wet year. And so it's really interesting to see that people, when they think that it snowed a lot, so therefore the soils must be, you know, saturated, but that isn't necessarily always true. And it would be interesting to compare over time the amount of snow that we get, what our streams look like, to that soil moisture, and see how those compare over time, because it's really hard to tell without long-term data. Because I don't know. It would be awesome to, back when before they put the reservoirs in, some guy was just like, wait, hold on, let me take soil moisture data. And then we would know, but we haven't. So this is a really new thing. Thanks, Nate.
You did a wonderful job developing a project that ties soil moisture to changing water conditions in the valley. Can you talk a bit more about the broader values of citizen science? For example, the slide you shared, and tie what you have heard about the disconnect between public knowledge and research.
Yeah, I think she's talking about this slide, which had a bunch of other just kind of values of citizen science. So I guess I'll just talk about a few of those. I think citizens, no one, without understanding what soil moisture means to people, like the fact that it influences our stream flow so much, it might sound like unimportant, like dirt, really, right? It doesn't sound like a lot. But I think being able to understand things like that, and the interconnectedness between all elements of our natural world, which is such a disconnect, I think, in modern science, as well as just our community, helps people understand that everything that, that they influence when they're on Spring Creek walking around, like being more conscious and aware of what that area means directly to the health of the rest of our city, is super important. But also it helps to get like government involved. It helps to get funding for these kinds of projects, to show more people the importance of these kinds of projects. And I also think citizen science is just really important in that it shows, like I was talking about, that we should get kids involved in these kinds of things, because it's really fun. Science is really fun. And I think sometimes kids get a little scared of like the hard parts of science, like the hard math and the hard aspects of it, that we forget to show them the fun. Hey, you get to go on a hike and scavenger hunt for these locations and take soil moisture measurements. So I think that is also a really valuable part of citizen science, is getting people involved and showing people possible career paths that they might go on, kind of stuff.